the distance, we can make the decision. Okay, an ultrasonic sensor transmit the ultrasonic waves by using a piezoelectric transducer. Okay, which convert the electrical energy into the mechanical vibration, which is generated in a high frequency sound waves. Or actually, you might ask me that high frequency means could we able to hear? No, we couldn't able to hear. There is three sound waves according to the frequency range. It is varied. So between 20 hertz to 20 kilohertz will be the audible range for a human beings. More than that we couldn't. Below to that we couldn't. So more than 20,000 hertz, that is 20 kilohertz, um, ultrasonic waves. Below to the 20 hertz, it's an infrasonic waves. So ultrasonic waves, some of the animals and some of the birds can produce, and they are using in their regular life. But naturally, we couldn't able to hear it. We also applying this ultrasonic radiation in some of the applications. I'll tell you what are those applications, how we are using that. Okay, there are emitted and ultrasonic pulses when the electrical signal is applied to it. Okay, yeah. The main component of the ultrasonic sensor is piezoelectric crystal only, which expand and contracts when electric voltage is applied to it. All right. There is a two things. One will be a transducer and the receiver. So transducer we will call transmitter and the receiver. Transmitter will send the ultrasonic radiation. Receiver will wait until the radiation will be echoed back. Okay. It's a simple system, like you're standing in top of a mountain and you're making a sound, hello or some name you're shouting. That has to be echoed. Now you will wait until the echo should be received. The same concept over here. So you will wait until the echo should be received back. Already this is a piezoelectric working of the thing. So electron flows like this. So whenever the voltage is applied to it, there will be an vibration started to produced. So I told you that what is ultra. Ultra means high, sonic means sound. Ultrasonic waves is a sound wave transmitted at a frequency greater than 20,000 hertz per second. Okay, below to this human audible range, I told you all right. 20 hertz to 20,000 hertz is an audible frequency. 20,000 above to the 20,000 hertz should be an ultrasonic ultrasound, and below to the 20 hertz should be an infrasound. So what is sound waves? So sound waves are generated by vibration, as we know. It required a medium to transfer from one place to another. It requires air, water, or a solid medium. It requires compulsory. Okay, that waves travel through air or water medium, and reflections of such waves from any object can be used to measure distance of that object. Okay, for example, you're shouting. It's a big auditorium. Okay, you're shouting in the one end of the auditorium. If you shout like that, how long you will wait to receive your echo? It will be very high. Right? You have to wait time will be very high. You need to wait for so long, and the sound will be very less. When you come in the middle of the auditorium and you start to shout, you will get echo very quickly. And if you moving very nearer to the wall means the echo will be very faster, right? You will receive that very faster. So the same concept over here. We will use the same concept, like waiting for the echo. We have to the distance. We have to calculate the distance. So ultrasonic sensors uses sonar technique to determine the distance to an object, like bats do. So we know that bats don't able to see in the daytime, but still, if it is stuck on any closed surface, it's moving. It's not hitting on any object. How it is happening? Because of the ultrasound only. It produces some sound, like crow and all producing sound na ka ka, and the parrots producing some other sound na. The same way, the bat also produces sound, but that sound we couldn't able to hear because it is not up to a human audible range. All right. So bat, what it will do is, when bat is nearing to the wall, continuously it will make a sound. When it is near to the wall, the echo will be very high, so it will take a diversion. Okay, in sonar, how we are using this one? A system for the detection of object underwater or in air by emitting the sound pulses and detecting or measuring their return after being reflected. All right. So we know that inside the water we couldn't able to see using a light. If you have a doubt, you just go to your home and you might have any while your parents cleaning the tank. You might ask them to show you, or they ask them to record a video to show you. What you ask was, just take them to flash a light on the water tank. Okay, is that your water is fully hitting on the bottom of the water tank? It won't, because the light won't travel faster in the any medium. The traveling of light will be faster in the vacuum only. Okay, whereas sound require any medium to travel. That is, if you clap, the sound is very high. If you do like this, the sound is high. I am talking, you can able to hear my voice through the air medium. So these are the mediums to transmit the sound. So inside the water also we couldn't able to find the seabed or any ice bar or mountain or something inside the water. So when we pass the sound radiation inside the underwater, if it is reflected very faster, so we can find that something was there in front of it or in the bottom. We can act accordingly. Okay, sonar technique is not something extravagant that humans have developed in recent years. It has been used by the animals. I told you, know, bat using this, and even the whales also using to communicate with each other. Okay, so for ultrasonics, I told you we are going to use that. I told you the ultrasonic module was HCSR04. This is the ultrasonic sensor module. So it has a 4 pins: VCC, trigger, echo, and GND. The operating voltage of this sensor is as usual 5 voltage only, and there will be trigger and echo. Trigger and echo means this trigger is a signal which is going out from the sensor. When it on any object, it will wait for the echo signal. That will be an echo. It will be received through the echo signal. So echo will be an input, and trigger will be an output. The TR is there now, that is transmitter and the receiver. It's not a heist, okay? It's a transmitter and the receiver. So transmitter send the radiation, and the receiver wait for the radiation to be received back to the system. All right. So I told you VCC. VCC should be connected to the 5V. GND is a ground pin. Ground pin should be connected to the GND pin, and trigger pin is a trigger or to start the signal pulse. Okay, and the echo pin will be an output. It will remain output pin. It has to wait till it should be received back. The trigger will be there. If it is echoed, it has to come back. Okay, so how can we calculate the distance of the object? So distance is directly proportional to the time, as we know. This waves requires to come back at the receiving end. The more the time taken, more the distance will be. All right. So whenever you are using the time here, we have to put T by 2. What this is T by 2 is? We know that D is directly proportional to T. D is equal to S into T. Distance is equal to speed into time. That's what's the distance formula in mathematics as we learned. So yeah, V is also nothing but is in velocity. We can define the V is V and velocity. So V, yeah, D is equal to S into T, right? Here we have to put S into T by 2. All right. T by 2 means twice of the time taken to reach and receive back the signal. The speed of the sound will be 340 meter per second. Okay. It is in SI unit. We couldn't able to change this one. Yeah, I just show you the connections and everything. Take it to printer. Okay. The board. What did you know? Ultrasonic sensor and buzzer. So take a GND and make it as a common over here. 5A to the VCC, GND to the negative. The short tail to be on GND. Trigger pin should be on pin number 2. Go to pin. And then the posture of the buzzer to be on 4. All right. Trigger is 2. Echo is 3. And the posture pin is on pin number 4. Now the coding part. We have to create a variable here. Variable. Create sound. Okay. Set sound. Input. Read ultrasonic distance sensor. So echo pin is on, sorry, trigger pin is on 2. And echo pin is on 3. Control block in control if statement. Okay. Math. Less than or equal to operator. So less than. Sound is less than 30 centimeter. It has to on the buzzer. If it is greater than that, it should be off. Greater than means nothing was there in front of it, right? So yeah, if it is anything was there, it should on. If it is nothing was there, it should off. So if it is there, the pin number 4 should on. I mean the buzzer should buzz. If nothing was there, the buzzer should go off. If it is greater than that, off. See here. So here 113.4 centimeter. So that buzzer is not buzzer. So if it is less than this, less than 30, then that off. Less than that, hope this will be clear for you. Let me do the code. I mean text code. In text code, we supposed to read the value. Okay, like we need to create a variables, a distance and the time variable to calculate distance of an object, and then we need to create and one more thing to be check that whether it is greater or equal to. So let me remove this. Hint, trick, here is on 2, hint, echo on 3, hint, buzzer is equal to 4. Voice setup. In mode. So come on. Output. Input, comma input. In mode. Buzzer, comma out. Void loop. First of all, we need to make a sound now. So while you're waiting for the echo to be received, we need to make a sound. Then only we can able to wait. So to make that, we have to on the sensor for a fraction of a second. For that, digital write trick, comma high. First, we'll make it to be low to ensure that nothing, no signal was leaking from the sensor. I mean, not go anywhere. Once it is done, delay a very fraction of a second. So then digital write trick, comma high. Delay 100 milliseconds. Then delay, sorry, digital write trick, comma low. Okay, once it is done, here we need to wait for the echo to be reach somewhere. In time, or you should not define time at all. Duration. We have to calculate the time of the signal to time of the duration, how long it takes to go and get back to the system. So duration. So already we know time, right? 343 meter per seconds. Whereas we have to know the time, then only we can able to calculate distance. So yeah, duration is equal to pulse in. It's a new command you are reading from here. This pulse in echo, comma high. So when the pulse is into the it should be high now when it is received. That has to be read as in duration of it. So once duration is detected, int distance equal to, the formula will be very big, right? 0.034 into, because we need to convert it to milliseconds, divided by 100. So then once we done that, we need to attach with this t by 2, right? That is duration by 2. 0.0034 into duration by if distance, sorry, if distance is less than 30, it has to turn on the buzzer. Digital right Buzzer, comma, high. If distance is okay, is to right. Buzzer, comma, left. Already, I have kept the code right. That is not executed again. Oh, sorry. Alison, it is pushed in. Again, variables according to his values less than 10 stopping, it working oppositely. So you need to change that. That's it. So value should be changed from 30 to be 10 and 10 to be 30. That's it. So if you do like that, your thing will be works. And without further, I'll show you what's the application of this. We can create a doorbell system, not only obstacle detection also. Yeah, this is mainly used in an home automation. So when somebody was standing in front of your door, you don't know who's standing there at all. Instead of pressing the calling bell, you can automatically indicate you that somebody was standing in front of your door. So, okay, in COVID time and all, these systems become bloomed because of not touching anything around us, right? And then yeah, not only that, okay, so distance reduction is used in so many advantages, like for car also. So when the car is moving near to any walls, it will automatically stop. Like that also we can design. Stop sharing from here and take you to the PPT. The application blind man stick, smart blind man stick, we can do the same thing. You're not going to create any additional things, any additional things. We are going to use the ultrasonic sensor, same Arduino breadboard, and the buzzer. But the thing was, you're going to fix all things in the stick. Okay, you should mount that everything on a stick so that the stick when the stick is facing the ultrasonic sensor should face on the walls. Okay, so when they are moving in front, if it detects anything, it automatically bursts, so that they will take a diversion. So normally, what they will do is, while moving, they will keep their stick and find it something was there or not, like that, right? That will be avoided. And you might ask me the questions, ma'am. Okay, you are telling that we use for a blind man while walking, if to find something in front of them. If they wanted to, if they wanted to know that what is there in front of, I mean downside, how could they use it to analyze it? Another sensor we have to keep on that. Okay, there will be vibration sensor to say something was difference in front in the level of variations, like level of the surface, like that we can use. Okay, and the robot navigation also we can use. So yeah, when the competition arena and all, they'll give you the obstacle reduction car. So the car should move, or the car should avoid something was there in front of it, and it should move accordingly. And car parking systems mainly. So when you're parking a car, we need someone's help, or we have to see clearly. We have to see the mirror carefully to check whether it's not hitting on the wall or it is not hitting on any car which is next to the parking. All the things we have to check it out. That will be avoided. Okay, even we can keep this on the parking area itself to check the availability of the cars also by using IoT systems. And then the industrial automations, we are using this same systems to do the many stuffs over there. And the biggest thing is, what is the advantage of this? What is the advantage of keeping this system? This is a low cost, okay, and which is easy to build. Can easily, I mean, it can measure the range, a short range only, but accurately finish. The thing was, how long, you might have a question that how long this ultrasonic sensor can able to detect or measure the distance. Can able to measure the distance from 255 centimeter alone, not more than that. Okay, it can able to detect 1 feet from 255. I kept my object very far when compared to 55. I'm just keeping a 300 centimeters. So whether it will detect or not, what it will put will be 255 centimeter only. Even you're facing something on your also it will show you if the roof also it will show you that 55 only the even though the range is very big. Okay, the range of the ultrasonic sensor is that only it can able to measure that, not much. All right. So we can design the obstacle avoiding car by using three ultrasonic sensors. So one can detect the left side, another one can detect the right side, and one should be on the front side. Like that, we can create, and that should work accurately. It won't hit on any object, and it will navigate inside the. All right. So whereas here, before and all, what we have done was we directly kept the digital read to reading digital read of that sensor where you connected that we mentioned. Whereas here, we have a two things that is ultrasonic sensor has a trigger pin, echo pin. Trigger and what is echo we need to define, right? So here that's what we just on the signal fraction of second to go out and get ready to return, I mean pulse into it. So it will wait how long it takes to get it back. That is a pulsing signal. So it will wait until that. Okay, that's a distance we have to calculate. So once the distance is calculated, once the duration is calculated, then we need to put that in a distance formula. So once the distance formula is done, we have to keep the speed of the sound and then the duration. It will give you the output. Yeah. We can make a little bit smarter. Then we can attach one more LED with it. So as usual, we need to create a variable. ultrasonic 2, 3. If less than 10, on the buzzer and the indicator means should be off. For the 30. Use of using resistor here. So that shows. If I give the value is less than this in block code, it starts showing less than 10. So when you keep it 30 or 50, it will works fine. Okay, but in a real-time application, while you're using anything, it will work. I mean, 30 if you keep, or 20, 10 or 20 if you keep, it will accordingly. But thing was that fraction of distance it will detect. Make sure that nothing while working with the ultrasonic sensor, nothing should be in front of it. Okay. Uh, by keeping the obstacle only, it should be on the front end, but nothing then should be kept in front. This is how you can create different projects. Uh, Advantage as we saw, it's very low cost and easy to build and accurate within short range. Any doubts on this? So one more class will be there. I mean, the last session. In last session, we are going to make another project, and that will be very interesting too. We'll see you next class. Thank you.